Hey guys, it's Mark. Quick video today on how we're going to hook up the AC side of our electrical system. I didn't see too many videos after that highlighted this portion of it, and I thought it was pretty important, so I wanted to talk for a little while about how we're hooking up not the entire electrical system, just the AC side of it. So this is our electrical system, and I'll post another video talking about what all the individual parts are and what everything does and how everything is interconnected. But for today, we're really just going to concentrate on the AC portion, which is going to go right there. And the heart of the AC side is really our Renogy 3000 watt inverter. So this guy's job is to take incoming DC power, and you see we've got these massive cables going to our Lynx distributor, which is our bus bar. It's fused there, and then it comes to our 200 amp hour battery bank. So these are feeding our inverter through these massive 4-aught cables. We've also got shore power being fed in through this 10-3 cable, and it goes basically through the roof and comes out that end where it feeds a 30 amp inlet. So that's where shore power comes in. The other end of shore power is right here. And this, once it starts putting out AC power, it does so on this one remaining cable. So the other end of this cable is right, let me see if I can grab that, is right here. So you can see I've already got a ferrule put on one end to start getting ready to attach it to our circuit panel. Now this is 10-3 marine grade cable. So don't use Romex or whatever you get at Home Depot. You want stranded cable for your van. It's pretty important because there's a lot of vibrations. You don't want anything to come loose. So this is 10-3 stranded cable, and just like at your house, you've got one cable that comes in that feeds your main circuit panel, and then you've got breakers that break that power into individual circuits. And we're really going to need to do the same thing in our van. So you can think of this as our incoming feed, and this incoming feed is going to go into this circuit panel. It's going to get broken down into two individual circuits, and that's going to feed our AC outlets. It's also going to feed our water heater, and it's going to feed our induction cooktop. So I've got to spread those loads over these two circuits. So let me show you how I'm going to connect this. Now if you look here, remember the incoming wire is going to have a positive, a negative, and a ground. So we need a place for each of those to go. So our negatives, our neutral is going to go right here to the neutral bus bar. Now this is not touching the circuit panel box. So this is what they call isolated. It sits up on this kind of plastic post. So only the white neutral wires will go here. We installed a little ground bus right there, and that is attached to the metal box. So we'll attach all our green wires to there, and those green wires will then feed back to a central grounding point that we have right there. And the only other thing is the hot side. So once the wire comes through here, we'll go ahead and pigtail that hot side to these two. That will spread that electricity into both these circuits, and then the individual circuit breakers that sit in these spots will then, whether they're on and off, will feed electricity to their branch circuits. So now we've got to consider what type of breakers we're going to put in this box. We've got two slots. Now we've really got two big devices that we've got to account for, and we've got a little bit of an issue with the amount of total power that's needed, but we know that, so we're going to work around it. So we've got an induction cooktop, and when both burners are on full tilt, that thing draws 1800 watts. Now 1800 watts divided by the voltage, which is 120, gives us 15 amps. So we know we could actually run that circuit on a 15 amp circuit. It's probably a little close to the top, so we're probably going to do a 20 amp circuit for that one. The water heater is the other big device. Now that one gets up to 1440 watts. Again, we divide that by 120 volts and we get 12 amps. So with that one we could safely run on a 15 amp breaker. So what we're going to have is a 20 amp breaker and a 15 amp breaker. Now if you do the math, you're going to realize that just those two devices can get us up to 27 amps out of our possible 30. So we just have to know that we probably will not run those two devices together. And if we have to run them together, it's probably not a good idea to plug in a blender or hair dryer or anything else like that. Now, this is the same thing in the house, right? I know I've got certain rooms at my house that if I plug in the vacuum cleaner while other things are going on, I'm going to blow a circuit. It's okay. I just know it's not a big deal. I just know not to plug in the vacuum cleaner into that specific circuit, or not while other things are running. You just work around it. And we'll do the same thing here in the van. So it'll be two circuits. We'll have a 15 amp breaker on one, and that's going to be mainly to power our hot water heater. The other one will have a 20 amp breaker, and that one is mainly to power our induction cooktop. And each of them will probably have an AC outlet or two tied to that one as well. So here we've got our two circuit breakers that we're going to use. We've got a 15 amp and a 20 amp. So the 15 amp is going to use 14 gauge wire, which we have here, and the 20 amp is going to use 12 gauge wire, which we have here. So both of these are that marine grade stranded cable, which you want to use for your van environment. So now we've got to cut them and get them into our box. So I've kind of prepped the box. This is where those two circuit breakers are going to go. And I fed in that 10 gauge XXX wire. Here's the wires that come out of it. So I realized pretty quickly that those two pigtails were going to take up way too much space in this box. So I went ahead and just ran a jumper cable between these two. This is also 10 gauge wire between these two positive terminals. And then the main wire comes back to here. So we've got the positive, we've got the hot wire that feeds these two terminals. We've got the neutral wire that runs to the neutral bus bar, which is here. And we've got the ground wire. And it's a little hard to plug stuff into this ground bus bar. So I went ahead and removed it. And we'll just feed all the wires into it. And then we'll screw it down to the box right here. So the box is grounded as well. So the next thing we're going to do is put our remaining wires in here. So we'll take off we'll loosen this stress nut right here, and we'll put in a strand of 14 gauge wire and a strand of 20 gauge wire. 12. So we'll put in a strand of 14 and a strand of 12, and then we'll start to make our connections. Alright, so this is the 14 gauge side here, and this is the 12 gauge. So now we've got to go ahead and do the same thing. We're going to connect the neutrals to the neutral bus bar. We'll connect the ground to the ground bar, and we'll connect the hots to the bottom of the fuses. So the hots will actually go into the bottom of the circuit breaker, so that when these are tripped, this shuts off. So, okay, now we strip some wires, make some connections. Bada bing, bada boom. All right, another thing we need is a ground wire that's going to come. So we'll have to attach this ground wire to that ground point over there in the van. So I have this green wire, which I was hoping to use, but it's really thick. We really only need 6 gauge cable, and this is 10. We really only need 10 gauge cable, and this is 6 gauge cable, so it's really thick. So I don't think we're going to use it. So I think we're going to go to the store and buy some other, maybe 5 feet of some thin green cable, because green's ground, so we're going to keep it green. All right, so first thing we're going to do is attach all our grounds to this grounding point here. And since there's more cables than there are slots, I'm going to double up. Okay, so all the ground connections are made. Now we're going to feed these, and we're probably going to have to cut them a little bit shorter because we want to feed these into these two. If we could reach around, we could get them here, but we'll probably do something like this. So we're going to cut these a bit shorter. Okay, so all our negative connections are made to the negative bus bar. All our ground connections are made to the grounding bar, which we will attach to the frame itself. The hot wire goes to this lug, which is now daisy chained to here. So all our real connections are made. All we've got to do now, besides for add that ground wire, is attach these guys. So this goes to the 15 amp breaker because this is the 14 gauge cable. And this side will go to the 20 amp breaker. So at this point, all that's left to do is attach them, which is not going to be so easy, I don't think. All right, so this is the 20 amp side, and these have these snap connectors, so this clip snaps into this metal piece here, and this clip snaps into this plastic down there. This can be plastic, right, because the connection's going from here to here, so it doesn't matter what, that's plastic. I think the back has to snap in first, and then we hope we can reach the front. Actually, I think the front maybe goes in first. That's one. And that's the other one. So, at this point, both are off, and we're not going to close it up yet because we've got to add that other ground wire. I could actually close this off and I could just drill a hole here, put a screw in there, and attach the ground wire to the screw. Or probably could attach the ground wire to one of these things actually, so I probably could go ahead and screw this in. But from electrical connections, aside from the ground, this is done. So we're going to go ahead and test this. So I'm going to go ahead and plug in the shore power adapter, shore power inlet, see what happens. So here's what we're going to do. We are going to fire up this this 15 amp circuit, and the only thing I've got connected on the 15 amp circuit is a outlet over there, and we should see the outlet. There's a little meter in there. We should see it light up when we do this. So we're going to do it now. By the way, I don't suggest playing with these things without a cover on them, but all right. We turned it on, and now we're going to look up here. And it's not on. Huh. Oh, the inverter has to be turned on. Duh. All right. Hold on. We got to turn on the inverter. That's what we need to do. Button. So the inverter just kicked on. Still ain't working. The inverter is on. There's no reason this should not be working.
There's lights on there.
This is pretty uneventful if you're watching this video. Hold on. I think I figured out what the problem is.
Me.
No, I wired them backwards. So when I turned on the 20 amp circuit, which is this one, this went on and it shows correct polarity and everything. So that means those two black wires that go into the circuit breakers need to be switched. That one needs to go there and that one needs to go there. Small problem.
At least she found that now.
Yes, it's all good. Let's fix that.
Okay.
Okay, we have switched the wires around. We are going to turn on the 15 amp breaker. That's what it sounds like when a 15 amp breaker turns on. We're going to turn on the inverter and we should get power over at that outlet. All right. Two lights on showing correct polarity. Ground is hooked up. And that is it. So now all we've got to do is, well, we've got to wire up the, by the way, don't touch these things like this. I mean, don't stick your hands in there. That wouldn't be good. So what we've got to do now is find if this needs a ground wire from here to there. What I'm going to do is get my ohm meter working, and I'll put one here and one there, and if they show no resistance, then I know this is already grounded through the inverter and we don't need an extra wire. If we do need a wire, we'll plug it into one of those, run it through here to that point, and then we will put a lid on this and stick it right here. That's the next step. Okay, we are back in the van. We got a new battery in our meter and we've got it set to read ohms. That's resistance. So what we got it set to is when there's no resistance, awful sound. So, right, if we connect these two to the bus bar, the ground bus bar, we hear that wonderful sound. Now, if this is grounded completely through the inverter, back through our Lynx distributor and to the ground point, we'll hear that same sound here. Let's see if we can get that. It is not. So I was hoping that this was grounded completely through the inverter and we wouldn't have to run another wire, but it sounds like we've got to run another wire. So we've got to get about 4 feet of a number 10 wire. I'll probably try to find a green flexible one because anybody getting into the van and looking at the electrical system will see green and know it's ground. So that's it. Next stop, 4 or 5 feet of green wire and we'll be right back. All right, so we got our green ground wire. I've attached it to the ground point here, run it through the wheel well, out through here, along down here, and then it goes into the electrical box. Let me see if I can make that a little easier to see. So it comes into the electrical panel and winds around and attaches to the ground bus bar there. So now all we've got to do is seal this thing up and we are done. The ground box cover is in and it's good and tight. I've got both my circuits turned off right now. So we're going to go outside. And plug in our shore power once again. And I can hear our inverter clicking, or at least sensing power. The inverter is sensing 120 in, and when we turn it on, alright, so the inverter is now on. Our power is off. I'm going to go here and flip on the 15 watt, which I can't even tell which one it is. I think it's this one. I think that's it. And now we have the power. Grounded and everything. So, job well done. Hey guys, thanks for watching the video. Really hope you got something out of it and it helps you along with your own electrical build. As you can see, we are working on our Webasto heater. So we'll be back next week to show you how we installed this thing. So until then, if you like the content, please consider subscribing to the channel. Give us a thumbs up, leave a comment. We love hearing from you guys, and we will talk to you next week.